So we have introduction and elimination rules for each one of our 5 Boolean connectives. So far, we have introduced the introduction and elimination rules for the conjunction, the conditional, the biconditional, and the disjunction. So what's missing are the introduction and elimination rules for the negation sign. Now, the introduction and elimination rules for the negation sign make use of a special new symbol, which we are going to call bottom. So before we get to the introduction and elimination rules, we need to talk a little bit about this new symbol called bottom. So bottom looks like an upside down T, and this upside down T symbolizes a contradiction. So that means that you can think of it as shorthand for, say, A and not A. Now, we have both an introduction and an elimination rule for bottom, where the introduction rule for bottom justifies you to infer bottom from other sentences, and the elimination rule for bottom tells you what you can infer once you have bottom in your proof. So let's talk about both of these rules in turn. The basic idea behind bottom elimination is that you can infer anything from a contradiction. And this rule is also called explosion. Formally, it looks like this. Suppose that in line M of your proof, you have established bottom. That then licenses you to infer any sentence whatsoever and justify this inference by citing bottom elimination, or alternatively by writing a capital X standing for explosion and citing the line M that contains bottom. So you have a choice with regard to how you want to reference this rule. You can either write the upside down T and a capital letter E, or you can just write a capital X, and both citations reference the same rule. So here are a couple of examples. Suppose you have bottom in line M of your proof. That allows you to infer if A, then B. It really allows you to infer any sentence whatsoever. So in the second example, in the bottom left corner, I show an example where in line M you have bottom, and that then licenses you to infer that A or C if and only if B. Or if you look at the top right corner, if you have bottom in line M of your proof, that licenses you to infer A or C. And it also licenses you to infer if A then B, then C. And so on and so forth. So really, once you have bottom in your proof, you can infer anything whatsoever. Now, let's think a little bit about the justification for this rule, or the rationale behind it. 2 or more sentences are inconsistent if there's no valuation that makes both or all of them true. So that means that inconsistent sets of sentences are not jointly satisfiable. And as a matter of fact, arguments with inconsistent premises are always valid. So to explain why that is, look at this truth table here. Here we are seeing the truth table for an argument with 2 premises, A and not A, and the conclusion is B. Now this argument is valid just if and only if in every line of this truth table where both premises are true, the conclusion is true as well. And if you now look at the truth table, you will see that there simply is no line in which both premises are true. When A is true, not A is false, and when not A is true, A is false. So that means that vacuously, every line in which both premises are true is a line in which the conclusion is true. To put the point somewhat differently, an argument is invalid if and only if we can find a line in the truth table where both premises are true, but the conclusion is false. But if the premises are inconsistent, meaning that there's no valuation that makes all of them true, we simply won't find such a line. We won't find a counterexample that establishes that the argument is invalid. the basic idea motivating bottom introduction is that if you have shown that A, and you also have shown that not A, for any sentence A, you can infer bottom. Now this makes a lot of sense, given that bottom simply symbolizes a contradiction. So formally that means that suppose that in line M of your proof, you have established a sentence of the form A, and in line N of your proof, you have established a sentence of the form not A. That then justifies you to infer bottom, and to justify this inference, you need to cite bottom introduction as applied to lines M and N of your proof. So here are a couple of examples illustrating the use of this rule. Suppose that in line M you have the conditional if A then B, and in line N you have the negation of this conditional. It's not the case that if A then B. You can then infer bottom and justify that inference by citing bottom introduction as applied to lines M and N. Or suppose that in line M you have the sentence if A or C then B, and in line N you have the negation of this sentence. It's not the case that if A or C then B. Again, you can infer bottom. And so on and so forth. Suppose in line M you have the disjunction A or C, and in line N you have the negation of this disjunction, you can infer bottom. Or if in line M you have the negation of the conditional, or you have the sentence, it's not the case that if A then B then C, and in line N you have the sentence if A then B then C, again you can infer bottom. So all that's needed is that in one line of your proof you have a sentence, and in another line of your proof you have the negation of that sentence.